Hello everyone, welcome back to the channel. In the previous video, we have seen how we can draw two different types of datasets with an inverted y-axis and a normal y-axis to be able to understand the data in a better manner. If you have not yet seen that video, you can find the link of the video in the description. In this video, we will discuss about the concept of flow direction and also write a code about how we can calculate the flow direction of each cell using DEM data. Flow direction is generally used to determine the path of the water flow so that we know the river in a catchment. So let's directly go in and understand the concept of flow direction and its code. So let's directly see about the flow direction concept. So if we see here, flow direction, if we assume the dataset which we are seeing on the screen as the digital elevation model datasets, which shows various elevation datasets like 90, 89, 89 and so on. Let's say they are in terms of meters, and we want to find out how the water is flowing from each cell to the next cell. So let's assume this data. So let's assume 87 is the cell where we want to find the data. So if we see that 87 is the elevation from which we are saying the water is starting to flow, how will the water flow and what is the direction in which the water can flow? So to determine that, we need to check the 8 directions of each cell. We are choosing 87 as the cell, so we see all the 8 directions as we see here as north, south, west, east and the other 4 diagonal directions. So these are all the cells where we are seeing star are the locations where we will see the elevation data set and also sometimes see the slope based upon the difference in elevation and distance. So based on these locations, if we again see that 87 is our center cell, so where will the water flow from there? So if we see here, the lowest elevation is 86, and assuming that the slope difference based upon difference in elevation to the distance is lower in this direction, the water flows from 87 cell to 86. So in this way, when we think about how the water will flow from 86 to the next cell, we again see all the 8 directions and see where the water is capable of flowing. Here we can say that the water is able to flow to the 85 elevation because the elevation difference is higher there compared to the other cells in the 8 directions. In this way, for each cell we will determine the elevation difference and the distance values to determine the slope. If the steepness of the slope is higher, it goes there. Generally, when an elevation between two cells is lower than the upper cell elevation, water flows through this direction. So in this way, these are the cells where the water can flow. So if we see the path, it starts from 88 to 87, 86, 85, 83 and 82. So this is how the path of water goes in this DEM, and this is what we are trying to write the code for. So to be able to do this code, the one thing we need to keep in mind is to get good flow direction datasets, we need to have the DEM without any incorrect values in it. Because most of the time when the DEMs are made, there are issues related to sinks and depressions which need to be filled so that we don't have issues in our flow directions where we see that the water is getting accumulated in one cell and it's not going outside to any other cell. So that is one thing which we need to keep in mind while using the DEM datasets. In this current video, we will discuss only about the code of this flow direction, and in the further videos we will discuss how we can write the code for fill sinks or depressions so that we will be able to have a good workable flow direction maps. So if we see the code now, as you can see here, I've already written the whole code, so I will be pasting this code in the description. You can use it for your purposes, and I'll be going through line by line, not so quickly, so that you can understand a bit better of what the code is doing. So initially starting off with the first line here, I'm defining a function naming it as 88 algorithm. 88 algorithm, it simply means that for a certain cell we see the 8 directions. For a certain cell we will see the 8 directions to be able to determine how the flow of water is from that cell to the next cell. So that is what I am defining, and I am asking the inputs as the DEM dataset as you see here, and as well as the cell size. We'll talk about it in a few more minutes. We'll know why we need the cell size. So that is what I'm defining here as a function, and what I'm doing in the next line is, firstly I'm trying to understand what is the size of my DEM so that I can know how many rows and how many columns of data I need to iterate to be able to determine the whole flow direction in the basin. So here I'm just trying to say DEM of shape, which gives us the rows and columns of our data sets. So next, in the next two lines here, what I'm doing here is I'm creating a null data set, because once I am trying to find the flow directions, I need to be able to fill the data sets with various direction numbers so that I'll be able to know which direction is that cell contributing to. So I'm using the DEM shape files whole as the reference, and I'm creating flow directions and slope as you see here, because I'll calculate both, and based on the maximum slope itself, because sometimes the elevation difference might be same for the two cells but the slope might be different. So wherever there is a steep slope, the water will flow through that direction. So that is the reason why I am calculating the slope here as well. So once we have created the datasets, the next thing of importance is the possible directions. If you remember, in the earlier section we discussed about north, south, west and east and the other 4 diagonal directions. Here we will see what each direction is numbered as. Here, based upon 88 algorithm, I am numbering east as 1 and going anti-clockwise to be able to determine the direction numbers. So if you see here, 1 is shown as east, and northeast and so on are given as 2, 3, 4, 5, 6, 7 and 8. So that is how I'm going to represent my directions using the written code. You can change it upon your preference, but I'm using it so that it's convenient for me in this manner. So if you see here, 0, 1 represents as east, because 0 represents the row number, whereas 1 represents the column number. If we say 0, 0 is our cell of importance, the next cell to the east will be 0, 1. So that is the reason why you see 0, 1 here and east as the naming. Once we've defined the neighboring directions, whatever the 8 directions are, in the next directions, the next thing we need to do is we go to each row and each column to be able to determine what is the difference in elevation in the 8 directions, and then we'll know how the water is flowing. So to do so, what I'm doing here is I'm calling a for loop function to go from the 0th row to the end rows and 0th column to the end columns. So for each row it will go to each column and give us the flow direction. So what I'm doing in the next few sentences is, if the data is equal to the no data, I'm saying don't do anything there because I don't want to know any flow direction there. So it skips those cells and goes to the next cells. So that is what if continued does here. So once if the data of that cell is not equal to the null data set, it goes to the next cell and calculates what is the elevation of the current cell. So if we say the current cell elevation is 86, it checks the 8 directions to guess the flow direction. I'm just defining the maximum slope as negative, just so that our slope is always greater than that, and it iterates based upon the 8 directions and gives the slope. So here the DRDC represents the directions in which we are going to change our cells. If you remember, for east I've shown here, if you've seen 0 and 1, 0 represents the directions in the row and DC1 represents directions in the column. So here dr will be 0 and DC will be 1 for the east direction. So once we have known for each direction, where we are looping here using for loop, and if the neighboring cells are not no data, because we know that if the neighboring cells are the cells which are having no data and they are outside the boundary of our data sets, then they will not be the contributing cells. So we will omit those cells. So that is the reason why we are seeing if continue here. Once we know this, in the next steps we'll calculate the elevation difference and also slope. For slope, we need to know the elevation divided by distance so that we determine the slope of the cell. Whichever has the steepest slope, we will say water will flow in that direction. So to do that, we need to know the distance of the current cell to its neighboring cell. If the values are in the horizontal x-axis or the vertical y-axis, which are west and east and north and south, that means it's changing only in one direction, which is generally equal to the size of the cell. If we say it's moving in the east direction and the resolution of our data is 200, it means that the cell is moving from this cell to the next cell, which is 200 meter distance. And that is same in the vertical direction as well. But if we are talking in the diagonal directions, then we need to think about the inclined distance. So to be able to differentiate that, what I have written here is, if it is in east or west, that means the row value is not changing, only the column is changing because it is moving either this side or this side. So here I am defining the horizontal distance as the cell size, and vertical distance is 0 because it's not changing the row number. So the distance is generally equal to the 200 meters, but if we see in the vertical and horizontal distance combined, which is hypotenuse square is equal to side square plus side square, is generally not required, but I've just written it for pure clear purposes to make more clarity in this sense. So if we see the equation here, if we use this, the result would be 200 itself because the vertical direction is 0. The same goes for the next directions, which are north and south. With vertically it is changing, whereas the row numbers are not changing. So there itself we will get the distances which are in horizontal or vertical direction changes. Whereas when we think about incline, here if you see I've written else. So if the value is anything other than these 4 directions, then we will do the horizontal distance by square root of 2 and vertical distance by square root of 2 and add them up to know the diagonal distance. Another method is just taking 200 and doing the square root as the same thing and determining the value. So I've just written it because this is of my convenience. You can just instead of writing this else statement, you can directly say if the direction is the 4 directions, northwest, northeast, southwest, southeast, you can directly say horizontal distance is CS, vertical distance is CS, because it's changing vertical distance as well. It's going this side and this side. Then you will know the inclined distance, which is generally for a 200 meter cell, it is 282 point something meters. So you'll take the inclined distance. Once we know the distance values, because here we will know the distance values using these 4 lines, then our thing is to know the slope. We know the location of the current cell and also we know the neighboring location. So if you see in line 33 here, we already knew the low neighboring location, and then we use the distance values to know the slope for all 8 directions. Then, because we need to find for all the 8 directions, I am looping it for each direction. So firstly we will go to east and check the slope value. If the slope value is greater than maximum slope, the maximum is the default value which I have given, minus 9999. So for the first direction, our maximum slope will be whatever the slope we are getting for each direction. So I'm saving that direction and putting it into a neighboring index. I'm saying for this row, this column, the direction of that cell is, generally it starts from 0 in Python, so I'm adding it as 1 because I want to represent east as 1, the remaining so on and so forth. So if my first slope value is greater than default value, it will save as 1. Now what happens is it goes back again to this loop, goes to northeast, north, northwest, west, southwest, south, and southeast. It goes to all the 8 directions. For each time it checks the slope values as you see here. If the slope is steep in any other direction, it puts that value there. And then so on, it goes on until the 8 loops and then gives me the resultant value. The resultant direction is saved in minimum direction for all the 8. It overwrites it if it satisfies the value. If not, it remains the same. Then what I'm doing is, if you remember, I've created flow directions raster. If we go back here and see flow directions raster which I created, so I directly go to that raster, to that particular row and column, and assign the minimum direction value. And remaining, I'll do the same thing for slope because I also want to know the slope value. So once it is done, if all the rasters are done, it will run a loop for all the cells and it will return me the flow directions and slope raster. So this is the function which we created, but we need to execute it function, right? So to do so, I've just written a few sentences. If you see here, I'm defining another simple function to be able to run this whole code. I'm saying is process the DEM and save it. I'll give you the DEM TIFF file. You just give me the output, both TIFF files. One TIFF file would be my flow direction, the other would be my slope. So what I'm doing here is I'm asking my code to input the DEM data, read it and give the cell size. If you remember in our previous code here, CS is the cell size which we are asking it to give. So that is the reason why we are asking it. And then I'm saving the result into result directions, and this is the function which we created just now to do the AD8 algorithm. I'm giving the DEM and cell size, and finally I'm saving 2 rasters into TIFF files. The first one would be my flow directions, and the second one would be my slope. So I run it using input data and I'm giving the paths to my output data, and I'm running this whole function to be able to get the result. If we go and open, I've already run the data, I can run it again, and if we open QGIS here, so if we see here, this is the result we are getting. This is a basin of my study area which I'm working on. So I've just used this basin's DEM to get the result, and as you can see here, these are the 8 directions in which it is showing that the water is flowing. So if we just do this and we are giving it into a color palette, we can classify the data, and if we see here, this is how the water is flowing, and this is the river in which the water is flowing. Because I'm working on this basin, I know where the river is. So this is how the flow direction code works, and it gives you the result of flow direction. I will provide this code in the description so that you can use it for your own purposes. We will see how we can further improve this code and also improve the fill sinks in the next videos. If you have understood this concept, please give this video a like, subscribe to the channel and share it with people whom you think this video could be useful.